हेलो स्टूडेंट्स, तो लास्ट क्लास हम लोगों ने आयनिक बॉन्ड किया था। आप लोगों को याद होगा, हमने केमिकल बॉन्डिंग के अंदर आयनिक बॉन्ड्स पढ़े थे और आयनिक कंपाउंड्स की कैरेक्टरिस्टिक पढ़ी थी। उसमें हमने लैटिस एनर्जी पढ़ा था, हाइड्रेशन एनर्जी पढ़ा था। हमने देखा था लैटिस एनर्जी किन किन फैक्टर्स पे डिपेंड करती है। याद है आपको किस पे डिपेंड करती है लैटिस एनर्जी? लैटिस एनर्जी डिपेंड करती है चार्ज और साइज ऑफ आयंस के ऊपर। आयंस के ऊपर चार्ज जितना ज्यादा होगा और साइज जितनी कम होगी, उसकी लैटिस एनर्जी क्या होगी? उतनी ही ज्यादा। सिमिलरली हमने हाइड्रेशन एनर्जी पढ़ी थी। हाइड्रेशन एनर्जी आपको किस काम में आती है? वो आपको बताती है कि आपका जो आयनिक कंपाउंड है वो सॉल्युबल होगा या फिर नहीं होगा इन वाटर। जितनी ज्यादा हाइड्रेशन एनर्जी उतनी ज्यादा सॉल्युबिलिटी। तो लैटिस एनर्जी और हाइड्रेशन एनर्जी दोनों आपके पास पार्टिसिपेट करती है इन डिसाइडिंग द सॉल्युबिलिटी ऑफ एन आयनिक कंपाउंड इन वाटर, जो हमने लास्ट क्लास देखा था। आज हम लोग स्टार्ट करने जा रहे हैं कोवेलेंट बॉन्ड, जिसके ऊपर आपकी केमिकल बॉन्डिंग ज्यादा बेस्ड है। तो सेकेंड टाइप ऑफ बॉन्ड इज आर कोवेलेंट बॉन्ड। तो आप अच्छी तरह जानते हो कोवेलेंट बॉन्ड क्या होता है। आपने छोटी क्लासेस में बचपन में मतलब बहुत बार पढ़ा है कि कोवेलेंट बॉन्ड क्या होता है। तो अगेन वी आर राइटिंग दिस डेफिनेशन, द केमिकल बॉन्ड फॉर्म्ड by mutual sharing of electrons between two atoms। दो एटम्स के बीच में अगर इलेक्ट्रॉन्स की म्यूचुअल शेयरिंग हो रही है तो वहां जो आपके पास बॉन्ड फॉर्म होता है, दैट बॉन्ड इज कॉल्ड a covalent bond. The bond formed by the mutual sharing of electrons between two atoms is called a covalent bond. So suppose we have an atom A and we have an atom B and both share one electrons. If these two are sharing one electron each, then there will be a bond formed between them which is called a covalent bond. आपने बहुत बार पढ़ा है। For example HCl, हाइड्रोजन के पास एक इलेक्ट्रॉन होता है, क्लोरीन के पास 7 इलेक्ट्रॉन्स होते हैं। तो क्लोरीन हाइड्रोजन के साथ एक इलेक्ट्रॉन शेयर करता है और क्या बनाता है? एक कोवेलेंट बॉन्ड। दिस टाइप ऑफ बॉन्ड इन व्हिच इज फॉर्म्ड बाय म्यूचुअल शेयरिंग ऑफ इलेक्ट्रॉन्स इज कॉल्ड अ कोवेलेंट बॉन्ड। नाउ विल टॉक अबाउट द कंडीशंस फॉर फॉर्मिंग अ कोवेलेंट बॉन्ड। सो राइट डाउन द कंडीशंस फॉर फॉर्मिंग a covalent bond. See, there is one and only condition, that the electronegativity difference between two bonding atoms either should be 0 और वेरी स्मॉल। कोवेलेंट बॉन्ड बनने की सिर्फ एक कंडीशन होती है, आपके पास जो दो एटम्स बॉन्ड बना रहे हैं, द इलेक्ट्रोनेगेटिविटी डिफरेंस बिटवीन दीज टू एटम्स शुड बी आइदर 0 और वेरी स्मॉल। फॉर एग्जांपल Cl and Cl, no electronegativity difference, bond form will be a covalent bond. H2, O2 and 2, these all contains covalent bonds. Again, less electronegative difference, HCl, CH4, CCl4, NH3, these all contains covalent bonds. These all molecules are formed through covalent bonds. तो covalent bond बनाने की सिर्फ एक कंडीशन होती है, the electronegativity difference either should be 0 or it should be very small. In general, if you want to classify, we'll say if delta En is electronegativity difference is less than 2.1, then bond formed will be a covalent bond. And if delta En is greater than 2.1, then bond will have some ionic character or it will be called an ionic bond. तो एक रफ डायग्राम ले तो आपके पास जो दो एलिमेंट्स हैं उनके इलेक्ट्रोनेगेटिविटी का डिफरेंस 2.1 से हमेशा क्या होना चाहिए? कम। तो आपके पास जो बॉन्ड बनेगा वो कैसा बॉन्ड होगा? एक कोवेलेंट बॉन्ड। बेसिकली कोवेलेंट बॉन्ड्स आर फॉर्म्ड बिटवीन टू नॉन मेटल्स। If you can see here, the bonds are found between two non-metals. Because जो metal और non-metal में बनता है वो कौन सा bond होता है? Ionic bond. जो दो non-metals के बीच में बनेगा वो bond कैसा होगा आपके पास? Covalent bond. So this is covalent bond, and there is only one condition for the formation of covalent bond, and that is the electronegativity difference should be very small. Now we'll talk about characteristics of covalent compounds. If we talk about characteristics, first is physical state. These type of compounds can exist in all solid, liquid and gaseous states. I'll give you some examples of each state. Solid, for example, graphite. In graphite there is a covalent bond between carbon-carbon atoms, diamond, silica, that is your Si. These are all solids. Liquids, bromine, which is in liquid state, CCl4, carbon tetrachloride, CHCl3, your chloroform, benzene. These are all covalent compounds which are liquid. Gases, H2, Cl2, O2, N2, SO2, CO2. These are all covalent compounds and all are gases. So they can exist in solid state, liquid state and gaseous state. In solid state, very less compounds are known. Only those covalent compounds will be in solid state which have large network of covalent bonds. Like in diamond, graphite, you have many number of carbon atoms which are connected through covalent bonds. That is why these compounds exist in solid state. Those molecules which have higher molecular weights, they have stronger forces of attraction. They have large force of van der Waals attraction between these molecules. So they can exist in liquid state. And further gases, molecules with lower atomic mass, lower molecular masses will exist in gaseous state. So if we talk about physical state, they can exist in solid, liquid and gaseous all states. Second one, melting points and boiling points. Their melting points and boiling points are lower than ionic compounds. Since in ionic compounds close packing was more, in these compounds close packing is less. So their melting points and boiling points are lower. But in general, if we talk, boiling points increases with increase in molecular mass. As the molecular mass of a compound increases, its boiling point will also increase. There will be some exceptions, we'll study them in this chapter alone. So in general, we'll say that boiling point of any compound will be directly proportional to molecular mass. As molecular mass increases, the van der Waals force between the molecules increases, so the boiling point of compound will also increase. If we talk about third term is solubility. See, covalent compounds are soluble in non-polar solvents. See, we'll apply a principle which says like dissolves like. Later in this chapter, we'll study polar and non-polar compounds. You will understand this thing there. But in general, we can say that polar compounds, or we can say covalent compounds, are insoluble in water. Generally, covalent compounds are insoluble in water, but there are some exceptions. So some compounds like alcohol, ammonia, these are all covalent compounds, but they are fairly soluble in water. The reason is due to hydrogen bonding. You must have studied, or we will study that in this chapter. We'll classify covalent compounds as polar covalent compounds and non-polar covalent compounds like HCl. In HCl, chlorine is more electronegative, so it will have negative charge, this will have positive charge. So this compound has become polar. So polar covalent compounds are easily soluble in water because oxygen is negative, positive attraction force. So this compound can be easily soluble in water. So solubility will depend on many factors, but in general we will say covalent compounds are less soluble in water, but they are more soluble in non-polar solvents like benzene, like CCl4. In these type of solvents, your covalent compounds are more soluble. This is your solubility. Then there is one more property which we can compare, that is electrical conductivity. In general, the compounds, covalent compounds, do not have free electrons. Since they do not have free electrons, they are bad conductors of electricity. But still there are some exceptions like graphite. Graphite is a covalent compound, but it is a good conductor of electricity. Why? Due to its layered structure, which contains hexagonal rings in which each carbon atom is attached with 3 other carbon atoms like this. I'm sure you have studied this and you also remember this. This is one carbon, this is carbon, carbon, carbon. So each carbon is having one unpaired electron, due to which graphite can conduct electricity. So in some cases they are conductors, but more generally covalent compounds are bad conductors of electricity. So these are some normal properties which you know, and we have discussed these things. But the important one, the important property is that a covalent compound or a covalent bond is rigid and directional in nature. We have talked about non-rigid and non-directional. So ionic bonds were non-rigid and non-directional, but covalent bonds are rigid and directional in nature. And that is why covalent compounds have a definite geometry and can show isomerism. See, a covalent bond is rigid and directional. For example, if I ask to you what is the structure of CH4, तो आप जब भी CH4 के स्ट्रक्चर बनाओगे आप हमेशा कैसे बनाते हो? ऐसे? You'll always draw the structure like this. You'll never draw the structure of CH4 like this. Never. Why? Because the structure, the geometry of CH4 is tetrahedral. So you'll always draw CH4 like this. Why? Because covalent bonds are directional in nature. This CH bond will form only in this direction. It cannot be formed in this direction. It cannot be formed in this direction. Covalent bonds are always directional in nature. They will be aligned in a fixed direction at a fixed angle. उसके अलावा और किसी भी डायरेक्शन में और किसी भी एंगल में अपने आप को अलाइन नहीं कर सकते. Similarly, rigidness. If a covalent bond is formed between Cl and Cl or C and H, Cl and Cl cannot come closer than this distance. It's the maximum closest distance up to which these two Cl atoms can come close. Similarly, carbon and hydrogen cannot come closer than this distance, and this distance is called the bond length. So a covalent bond is directional and rigid in nature. Their characteristic is their bond length, which is that these two atoms cannot come closer than this distance. So this is the important characteristic of covalent compounds which we will be using, and which this characteristic differentiate covalent compounds from ionic compounds. कोवेलेंट कंपाउंड्स की कोई ना कोई ज्योमेट्री होती है, जबकि आयनिक कंपाउंड्स की कोई ज्योमेट्री नहीं होती है. आपने आज तक नहीं सुना होगा NaCl की ज्योमेट्री लीनियर होती है या टेट्राहेड्रल होती है. बट वी डू से CH4 is tetrahedral, CO2 is linear, NH3 is pyramidal. That is why, because covalent bonds have directional nature and they are rigid in nature. So these were some important characteristics of covalent compounds. Now we'll be studying in detail these characteristics, the solubility, the boiling points, melting points, We'll be studying them in this chapter. Next, third type of bond. The third type of bond is, or before that, I'll talk about the strength of a covalent bond. This is important. Strength of a covalent bond. See, the strength of a covalent bond depends on its bond energy. And what is bond energy? You know, bond energy is energy required to break a covalent bond. Will be its bond energy, and strength of a covalent bond is directly proportional to its bond energy. Greater is the bond energy, more will be the strength, and vice versa. Greater is the strength, more will be the bond energy. Now, on which factors bond energy depends? See, bond energy depends on following factors. It is inversely proportional to bond length. Greater is the bond length. Bond length is the maximum distance up to which these two atoms can come closer. So, as bond length increases, bond energy will decrease. So on, strength will decrease. For example, if I take these two chalks, which one is easier to break, this one or this one? Obviously this one, because this is smaller. A smaller chalk takes more energy to be broken. Same is the case. Greater is the bond length, lesser will be the bond strength and lesser will be the bond energy. जैसे जैसे आपके पास बॉन्ड की लेंथ बढ़ती जाएगी, बॉन्ड दो एटम्स की जो डिस्टेंस भी क्या होगी, बढ़ेगी, अट्रैक्शन फोर्स क्या होगा, कम होगा, तो बॉन्ड की स्ट्रेंथ क्या हो जाएगी, वीक हो जाएगी. So greater is the bond length, lesser will the bond energy, lesser is the bond energy, lesser will be the bond strength. Second, it is directly proportional to bond order. What is bond order? Bond order is number of bonds formed. Between two atoms, like C single bond C, O double bond O, and N triple bond N. So bond order of this bond is 3, this is 2, this is 1. As bond order increases, bond energy increases, and as bond energy increases, strength also increases. So the bond strength or bond energy depends on these two factors, that is your bond length and bond order. As bond length increases, strength decreases. As bond order increases, strength increases. And then third character is delta En. Delta En is electronegativity difference. Greater is the electronegativity difference between two atoms, more will be the strength of covalent bond. Why so? For example, A and B, if A is more electronegative, it will have negative charge, it will have positive charge. Partial negative, partial positive, extra force of attraction along with this covalent bond. So due to this extra force of attraction, the strength of this AB bond will be increased. So greater is the electronegativity difference between two atoms, more will be the strength of bond. So these are some factors on which the strength of a covalent bond depends: bond length, bond order, and electronegativity difference. So this was all about the introduction of a covalent bond. The next type of bond is our coordinate bond. So we are moving on to the next part, the next type of bond. Which is known as a coordinate or a dative bond. What is this type of bond? See, the bond formed between two atoms. The bond formed between two atoms when, notice the definition, इस पे ध्यान देना, when the shared pair of electron is being provided by one of the bonding atoms. एक बार डेफिनेशन नोट करो, फिर बात करते हैं इसके बारे में. तो बेसिकली एक ऐसा बॉन्ड, द बॉन्ड विच इज फॉर्म्ड व्हेन the shared pair of electron is being provided by one of the bonding atoms. Say I have two atoms A and B, and there is a bond to be formed between A and B, but in this case either A or B, let's say A is providing the shared pair of electron. जो भी bond के लिए आपको shared pair चाहिए वो कौन provide करवा रहा है? A. This A is called donor atom because it is donating its electrons for the sharing, and B is called acceptor. And a coordinate bond is always represented by an arrow which point towards acceptor from donor. So the coordinate bond formed will be like this. So ultimately there is a coordinate bond formed between A and B. तो जब भी दो एटम्स के बीच में बॉन्ड बनना है और जो शेयर्ड पेयर ऑफ इलेक्ट्रॉन है वो उनमें से कोई एक एटम प्रोवाइड करवा रहा है तो उसे हम क्या बोलते हैं? कोऑर्डिनेट बॉन्ड. थोड़ा कॉम्प्लिकेटेड है, समझ में नहीं आ रहा होगा. विल सी विद एन एग्जांपल. सी देयर आर टू पर्सन्स A and B. This A is very rich and this is very poor. B is very poor. A के पास बहुत सारा पैसा है, इट्स अ बिलियनियर, ही इज अ बिलियनियर, पर इसके पास दिमाग नहीं है. इसको पता नहीं है बिजनेस कैसे चलाते हैं, वो पैसा वेस्ट करता है. तो कोई एक को एडवाइस देता है कि एक ऐसा बंदा ढूंढ, एक ऐसा पर्सन ढूंढो आप जिसके पास दिमाग हो, जिसका बहुत अच्छा दिमाग चलता हो, चाहे उसके पास पैसा हो या ना हो, लेकिन उसका दिमाग बहुत चलना चाहिए. ए अपनी सर्च स्टार्ट करता है एंड अल्टीमेटली फाइंड्स बी. बी वॉज वेरी पुअर, उसके पास कुछ नहीं है, बट इट हैज ए शार्प माइंड. बी के पास बहुत अच्छा माइंड है और वो जानता है कि बिजनेस को कैसे ग्रो किया जाता है. तो ए और बी के बीच में क्या डील होगी? सिंपल, पैसा मेरा, दिमाग तेरा. ए बोलेगा पैसा मैं लगाता हूं, तो अपना दिमाग लगा, हम बिजनेस ग्रो करेंगे. सो देयर इज अ पार्टनरशिप बिटवीन ए एंड बी. एक बिजनेस स्टार्ट हुआ जिसके दो पार्टनर्स है ए और बी, लेकिन इस बिजनेस में जितना भी पैसा आया है वो सारा पैसा किसने लगाया है? ए ने. मानते हो? ए क्या हुआ मेरा? डोनर. बी क्या हुआ? एक्सेप्टर, क्योंकि इसने इसके प्रपोजल को एक्सेप्ट किया, इसने इस शेयरिंग को क्या कर लिया है? एक्सेप्ट कर लिया. तो ये क्या हुआ? मेरा डोनर, और ये क्या हुआ? मेरा एक्सेप्टर. नाउ आप कुछ दिनों के बाद ए के पास जाते हो और ए से पूछते हो ये बिजनेस किसका है? तो ए क्या बोलेगा? मेरा है. चलो ठीक है. फिर आप गए बी के पास, आप बी से पूछोगे ये बिजनेस किसका है? बी क्या बोलेगा? उसका है. नहीं, बी भी आपसे क्या बोलेगा? ये बिजनेस मेरा है. ये पैसा एक्चुअली किसका था? ए का, लेकिन जैसे उसने शेयरिंग में डाल दिया, अब ये किसके अकाउंट में काउंट होगा? दोनों के. ये ए के अकाउंट में भी काउंट होगा और ये बी के अकाउंट में भी काउंट होगा. सो दिस इज अ कोऑर्डिनेट बॉन्ड. जो भी शेयरिंग का इलेक्ट्रॉन पेयर था वो किसने प्रोवाइड करवाया? ए ने. लेकिन शेयरिंग पे आने के बाद वो ए के बैलेंस शेल में भी काउंट होगा और वो बी के बैलेंस शेल में भी काउंट होगा. So this type of bond is called a coordinate bond in which one atom provides the shared pair of electron and the other atom accepts the sharing. The shared pair of electron will be counted in the valence shell of both A and. समझ में आता है? तो ये होता है आपका एक coordinate bond. And there is an important thing that a coordinate bond after formation is indistinguishable from a covalent. आप एक कोऑर्डिनेट बॉन्ड को एक कोवलेंट बॉन्ड से डिस्टिंग्विश नहीं कर सकते. आफ्टर फॉर्मेशन it will look alike a covalent bond. So this type of bond is called a coordinate bond in which one atom provides the shared pair of electron for bonding. This atom is called donor, this atom is called acceptor. The condition is one atom should be electron rich and the other atom should be electron deficient. For example, see this compound NH3. In NH3 nitrogen has one lone pair and BF3 In BF3, boron has only 6 electrons in its valence shell, but there should be 8 electrons in the valence shell. So boron is electron deficient and nitrogen is electron rich. So nitrogen will donate its electrons to boron and they will form a coordinate bond like this. This type of bond is called a coordinate bond. So we have completed all the 3 types of bonds: ionic bond, covalent bond and coordinate bond with their characteristics. Now we'll start off with Lewis octet rule, जो आप लोगों ने पहले ही पढ़ा है in junior classes, and you know what is Lewis octet rule. It says that each element wants to complete its octet. So we'll start with Lewis octet rule. ये रूल आपसे क्या कहता है? Each element tries to acquire 8 electrons in its valence shell. पहली चीज, हर एलिमेंट एक्सेप्ट हाइड्रोजन, क्योंकि हाइड्रोजन के केस में क्या होता है, हाइड्रोजन में एक ही शेल होता है, इसमें 2 इलेक्ट्रॉन आ सकते हैं. तो हाइड्रोजन हीलियम के बाद जितने भी एलिमेंट्स हैं, दे ऑल ट्राई टू एक्वायर 8 इलेक्ट्रॉन्स इन देयर वैलेंस शेल, एंड टू डू सो दे कैन शेयर, डोनेट और एक्सेप्ट electrons and thus form chemical bonds. लुइस के हिसाब से हर एलिमेंट अपने ऑक्टेट में कितने इलेक्ट्रॉन्स करना चाहता है? 8. And to complete these 8 electrons, this element can share, can donate or can accept electrons. This is the cause of chemical bond formation between 2 elements according to Lewis, that each element wants to have 8 electrons in its outermost shell, and for hydrogen and helium they want to have 2 electrons. So for this purpose they will accept, they will donate, they will share electrons. For example, HCl, hydrogen has 1 electron and chlorine has 7 electrons. Hydrogen wants to complete its duplet, 2 electrons. Chlorine wants to complete its octet, 8 electrons. So these two will share their electron pairs. Now chlorine has 8 electrons and hydrogen has 2 electrons. So by this sharing, a covalent bond is formed between hydrogen and chlorine. For example, sodium, 1 electron in its valence shell, its configuration is 2, 8, 1, and chlorine again 7 electrons in its valence shell. So sodium will donate its 1 electron to chlorine, it will form Na plus and Cl will form Cl minus, and a bond will be formed between Na and Cl, which is termed as an ionic bond. So this completion of octet become a cause of chemical bond formation between 2 elements. The elements form a chemical bond to complete their octet. So according to Lewis, those elements, or sorry, those compounds in which the octet of central atom was complete, they were more stable, and or we can say they were stable, they should exist. And those elements which do not have complete octet should not exist. Those compounds in which the octet of elements are not complete, they should not exist according to Lewis. But there were some compounds which do not have complete octet but still they exist, and those can be categorized in exceptions to Lewis octet rule. So our next topic is exception to Lewis octet rule. So what are these exceptions? We'll start with first. These are exceptions to Lewis octet rule. You can write the heading. Now first one is electron deficient molecules. You can also call them hypovalent. Hypovalent means less. 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 Hypovalent means less or you can name them as compounds, or rather molecules, with incomplete octet. There are some compounds in which the octet of central atom is not complete. So according to Lewis' rule, these compounds should not exist, but these compounds do exist and we use them. For example, boron trifluoride, BF3. In BF3, each boron atom shares one electron with 3 fluorine atoms. Like this, like this. This is the Lewis dot structure of boron trifluoride. So total electrons in the valence shell of boron are 2, 4 and 6. There are 6 electrons in the valence shell of central atom, that is boron. But according to Lewis' rule, there should be 8 electrons in the valence shell of the central atom. That means this compound should not exist, but this compound do exist. That is, it does not follow Lewis octet rule. Similarly, AlCl3, again this compound also have 6 electrons in its valence shell. It does not have complete octet. This compound also do not follow Lewis octet rule. BeCl2, 4 electrons in its valence shell, do not follow Lewis octet rule. So these are some compounds in which the octet of central atom is not complete and they do not follow Lewis octet rule. These compounds can be categorized in a specific category which is called Lewis acids. And what are Lewis acids? Lewis acids are compounds or molecules which can accept a lone pair of, or sorry, we can say them an electron pair, rather can accept an electron pair. So those compounds which can accept an electron pair are called Lewis acids. For example, BF3, it has 6 electrons. To complete its octet, it wants one pair of electrons, so it can act as a Lewis acid. So BF3, AlCl3, BeCl2, FeCl3, these all can act as Lewis acids. All those compounds which are electron deficient, which can accept one electron pair, are called Lewis acids. Is that clear? Now, second category of molecules is molecules with expanded octet. You can see them hypervalent. Hypo means less and hyper means more. So they have more than 8 electrons in their valence shell. So these compounds have more than 8 electrons in the valence shell. Of central atom. For example, PCl5. If we draw the structure of PCl5, one phosphorus is attached with 5 PCl, 5 Cl atoms, like this. 2, 4, 6, 8, 10. There are 10 electrons in the valence shell of phosphorus, but according to Lewis octet rule, it should be 8. So it does not follow Lewis octet rule. SF6, F, 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 F and 2, 4, 6, 8, 10, 12. 12 electron in the valence shell does not follow Lewis octet rule. IF7, F 7 2s are 14. 14 electrons in valence shell cannot follow Lewis octet rule. So these are hypervalent compounds which have more than 8 electrons in their valence shell. According to Lewis rule, there should be 8 electrons in the valence shell, but in these compounds, the electrons in the valence shell are more than 8. So these compounds also do not follow Lewis octet rule. Then we have third category of compounds which are called odd electron molecules. This is a very specific category of compounds. In these compounds, there are odd number of electrons in the valence shell of central. In these type of compounds, there are odd number of electrons in valence shell. For example, NO, nitrogen. How many electrons are there in the valence shell of nitrogen? It's 5. Maybe you'll be having complications, or you'll be having difficulties in finding the number of valence electrons. Just wait for 2 minutes. Let me complete this topic, then I'll let you know how we'll calculate the valence electrons in the central atom or in any given atom. Okay. So for right now, nitrogen has 5 electrons in its valence shell, and oxygen has 6 electrons in its valence shell. Total 11 electrons. NO2. Nitrogen has 5, oxygen 12, 17 electrons. ClO2, chlorine has 7, 12, 19 electrons. In these type of compounds, there is no possibility of completion of octet, because you cannot find an arrangement through which these odd electrons can be arranged such that there will be 8 electrons in the outermost shell. आप इन्हें किसी भी तरह से arrange नहीं कर सकते हो. So these all compounds do not follow Lewis octet rule, and keep in mind these molecules are paramagnetic in nature. What is paramagnetic? Paramagnetic substance is a substance which is being attracted by magnetic field, and those compounds or molecules in which there is unpaired electron will be paramagnetic in nature. In odd electron molecules, there will always be one unpaired electron, due to which they will show paramagnetic behavior. So this was the third class of compounds which do not follow Lewis octet rule. Now we are left with one more. Fourth one, cations with 18 electrons in their valence shell. See, we have two types of cations. First, cations with inert gas configuration. These have 8 electrons in valence shell, like sodium, magnesium, calcium. These are the cations with inert gas configuration. There is another class of cation which is known as pseudo inert gas configuration, and these cations have 18 electrons in their valence shell, and these are Cu plus, Zn2 plus, Cu2 plus, etc. These type of cations have 18 electrons in their outermost shell. So these cations also do not follow Lewis octet rule. For example, if we take copper, copper's configuration is 3s2, 3p6, 3d10, 4s1. Cu plus will be formed when one electron is being removed from copper and the electron will be removed from the outermost shell. So the Cu2 plus will have configuration, Cu plus will have configuration 3s2, 3p6, 3d10. This is third shell, outermost shell, valence shell, electrons 10 plus 6, 16, 16 plus 2, 18. So these were four classes of compounds which do not follow Lewis octet rule. First one was molecules with incomplete octet. Second one is molecules with expanded octet. Third one, odd electron molecules. And fourth one, cations with pseudo inert gas configuration, that is, which have 18 electrons in their outermost shell. So these were some compounds which do not follow Lewis octet rule. Now we'll see how we can calculate the number of valence electrons in an atom and how we will decide the central atom in a given compound. So our next topic is central atom and valence electrons. What is a central atom and what are the valence electrons in this central atom? See, we have central atom is the atom which is bonded or which share its electron pairs with other atoms. What we have to do is we have to find out central atom. To find out central atom, we have to simply follow two rules. Rule 1 says hydrogen can never act as central atom because hydrogen has only one electron which can be shared. So hydrogen cannot act as a central atom. It will always act as a surrounding atom. There is one central atom and all the other atoms are called surrounding atoms. Then rule 2, central atom is the atom which is first less in number and second is less electro. So central atom will be the atom which is less electronegative and less in number. You will combine these two rules and these two again to find out the central atom. For example, I write CH4, which is central atom. Carbon is less in number, but it is more electronegative. But since this compound contains only hydrogen and carbon, and hydrogen can never be a central atom, so central atom will be carbon. NH3, central atom, nitrogen, H2O, central atom, oxygen. Okay. So these are the compounds in which central atom is. So a compound if contains hydrogen and only one element, then that element will be the central atom. But if we see other cases like CCl4, chlorine is more electronegative, carbon is less electronegative, and carbon is also less in number. So central atom is that which is less in number and less electronegative. So carbon is your central atom. PCl5, central atom, phosphorus. SO2, central atom, sulfur, less in number, less electronegative. OF2, central atom, oxygen, less in number, less electronegative. XeF4, XeOF2, central atom, Xe. So you can find out central atom in any given compound by these two simple rules. One, hydrogen will be a surrounding atom and the central atom is always less in number and less electronegative. So this is how we find out central atom. Then our next task is to find out the valence electrons in the central atom. So we'll do that also. See, generally covalent bonds are formed, not generally, covalent bonds are formed between two non-metals. So we'll go with the P block. We have 6 groups in P block: 13th group, 14th group, 15th group, 16th group, 17th group, and 18th group. Now what you have to do is, you must remember what I am going to write here, what I am going to explain here. You must remember it. This is 13th group. This is called boron family. The elements in this family are boron, aluminium, gallium, indium, and tellurium. Most of the students remember these things by some phrases. आपको भी शायद वो phrases आती होंगी, नहीं आती है तो मैं आपके लिए थोड़ी phrases brief कर रहा हूँ, ठीक है? Don't laugh on them. आप उनकी बिना इनको आसानी से याद नहीं रख पाओगे. This is boron family. इसे हम बोलते हैं बैंगन, आलू, गाजर एंड थैला. ये आपको ऐसे याद रखना है, बैंगन, आलू, गाजर एंड थैला. This is your 13th group family. You have to remember the general configuration of all the families. इसका configuration होता है NS2 NP1, where N is the number of period. This is your second period. This is third period, fourth period, fifth period, sixth period. Similarly, next family is carbon family. This is called Kahe Sita Ji Suno Prabhu. Write down in your notebook, Kahe Sita Ji Suno Prabhu. The general configuration of this family is NS2 NP. Then third is your nitrogen family. इसे हम बोलते हैं निखिल पास सब बिंदास. तो किसी का नाम निखिल हो तो याद रखना, निखिल पास सब बिंदास. दिस इज योर नाइट्रोजन फैमिली. नोट इट डाउन. इसका जनरल कॉन्फिगरेशन होगा NS2 NP3. देन नेक्स्ट फैमिली ऑक्सीजन फैमिली. इसे कहते हैं हम ओल्ड स्टाइल से टीपो. टीपो मतलब चीटिंग करना. शायद आप में कुछ लोग टीपो का मतलब नहीं जानते हो. सो ओल्ड स्टाइल से टीपो. तो यहां पर इसका जनरल कॉन्फिगरेशन होता है NS2 NP4. दिस इज कॉल्ड ऑक्सीजन फैमिली. देन नेक्स्ट हेलोजन फैमिली. फ्लोरीन, क्लोरीन, ब्रोमीन, आयोडीन, और इसे हम बोलते हैं फिर कल बाहर आई आंटी. ठीक है? और कुछ लोग इसे और कुछ भी बोलते हैं, दैट इज फिर कल बाहर आई आरती. तो आपको जो बोलना बोल लेना, बट आपको इसे याद रखना है फ्लोरीन, क्लोरीन, ब्रोमीन, आयोडीन एंड एटिस्टाइन. एंड इसका जनरल कॉन्फिगरेशन है NS2 NP5. देन लास्ट इज योर नोबल गैस फैमिली. यहां पर एक हीलियम भी लाई करता है जिसका कॉन्फिगरेशन तो आप जानते ही हो. देन नियॉन, आर्गन, क्रिप्टॉन, जिनॉन एंड इसे हम बोलते हैं हीना, नीना और करीना की जेरोक्स रानी. हीना, नीना और करीना की जेरोक्स रानी. इस फैमिली का जनरल कॉन्फिगरेशन होता है NS2 NP6 एक्सेप्ट हीलियम जिसका कॉन्फिगरेशन होता है 2s2. तो वो हम उसे यूज इतना नहीं करेंगे. मेन हमारे पास ये है. अगेन आपको सबके जनरल कॉन्फिगरेशंस पता होने चाहिए, जो बहुत बड़ा टास्क नहीं है. फर्स्ट है यहाँ पे इलेक्ट्रॉन P ब्लॉक एलिमेंट से, तो इलेक्ट्रॉन P शेल सब शेल में एंटर करेगा. NS2 NP1 NP2 NP3 NP4 NP5 NP6 NP5 एंड NP6. नाउ दिस इज nth शेल. इस ग्रुप के सारे एलिमेंट्स के वैलेंस शेल में कितने इलेक्ट्रॉन्स होंगे? 2 + 1 3. इस ग्रुप के सारे एलिमेंट्स के वैलेंस शेल में कितने इलेक्ट्रॉन्स होंगे? 2 + 2 4. इस ग्रुप में 2 + 3 5, 2 + 4 6, 2 + 5 7, 2 + 6 8. तो अगर मैं आपसे बोलता हूं सल्फर के वैलेंस शेल में कितने एटम्स हैं, तो सल्फर इस फैमिली से बिलोंग करता है. 2 + 4 6. फास्फोरस 2 + 3 5. क्लोरीन 2 + 5 7. So this is how we find out valence electrons in the central atom. Again, आप इनमें से किसी का भी कॉन्फ़िगरेशन लिख सकते हो. फॉर एग्जाम्पल मैंने आपसे कहा जर्मेनियम का कॉन्फ़िगरेशन लिखो, तो जर्मेनियम इज इन फोर्थ पीरियड एंड जनरल कॉन्फ़िगरेशन इज NS2 NP2. So the configuration of germanium will be 4s2 4p2. For example, if I have to write configuration of sulfur, sulfur is in third period, general configuration NS2 NP4, so it would be 3s2 3p. Silicon 3s2 3p. Iodine fifth period 5s2 5p 5. Number of valence electrons 7. Argon third period 3s2 3p6. Number of valence electrons 8. Aluminium number of valence electrons 3. Configuration will be 3s2 3p. So this is how we find out the valence electrons in the central atom, and we can write the configuration of any of these atoms. Is that clear to you? So this was our introduction to chemical bonding. We have studied ionic bond, covalent bond, coordinate bond, and Lewis octet rule. In the next class, we'll start off with valence bond theory.